The students have already made this drawing in their notebook, and we're going to start out with a couple of review questions. What's the only thing that you can say for certain based on just my drawing here, or what's the most obvious certain thing that we know we have here? Peyton?
There are two parallel lines.
Very good, and we know they're parallel lines. Peyton knew it because of those arrows. Those remind us that. That's telling us those lines are parallel, even if they don't quite look like it to us. They are. So if we have parallel lines, we know those three relationships we talked about last week are holding true. Knowing that, can somebody name a pair of alternate interior angles for me? Any pair of alternate interior angles. Sophia? C and G. Very good. What do we know about alternate interior angles? They are equal. Very good. Can anyone name a pair of alternate exterior angles? Because we also talked about alternate exterior angles. Lauren? E and A. Very good. And do you remember what we know about alternate exterior, Lauren? They are equal. What about corresponding angles? We also talked about corresponding angles. They're a little harder for kids to pick out at first, right?
F and H.
F and H. And what do we know about them?
They're the same angle.
They are the same angle, which is equal. Can you name another pair of corresponding angles? Because there's a bunch of them. Julie?
G and N.
G and E. Very good. All right, so that's good review. You know all of that. You guys seem like you're processing it well. That's great. Now today we're going to talk about some same side interior angles. Okay. So just based on how I'm describing it, who thinks they can name a pair, God bless you, Brian, of same side interior angles? Looking at my picture. Jack?
B and C.
Angle B and angle C are same side interior angles. Can somebody name another pair? Because there is another pair. Peyton?
G and F.
Very good. Angle G and angle F. Okay, now looking at our picture, and let's just look at the first set, angle B and angle C. Do you think they are equal like those other three kinds of pairs? Why or why not? Think they're equal, why or why not? What do you think? Shri?
No.
No? Just because they don't look it, or?
Because like they're on like this different spots, so they can't equal.
They're in different spots, so they can't equal each other. Okay, Angela?
One's obtuse and one's acute.
Yeah, this one's obtuse and that one's acute. Clearly they can't be the same. Does anyone think that they know what they are and has a good lawyerly argument for what they are? Carolyn?
It's supplementary if you put them together.
Okay, and why do you think that? What's your argument for it?
Because they're opposite.
Because they look it, kind of?
Yeah.
Okay. All right, let's see if we can put some meat behind that argument. All right, Peyton?
Because F and H are the same, so and you know that F and G equal 180, so I mean H and G equal 180, so you know that F and G equal 180.
Oh, okay. So how do you know F and H are equal to each other, Peyton?
Because they're corresponding angles and they're the same.
Yeah. So F and H equal each other because they are corresponding angles. And then this angle and this angle are on a line, so they total 180. So if this is the same as that, then they must equal 180. You could put this is the same as F right there, and you can see that it has to be 180. So good. All right, so we can say that these are total 180. Different kind of relationship than our equal things. Any questions? Sometimes kids use corresponding angles like Peyton and Nathan did. Sometimes they use alternate interior angles like this, that they know that F and B must equal each other because of alternate interior angles, and then B's equal 180 also. Either one is a fine argument. Okay. All right, let's move on. Go ahead and make this sketch quick, and then we'll talk about it. Okay, so in this picture, usually what happens is that kids look at it and they go, about half of them will say, I don't know, I don't get it. And then another quarter of them will go, well, 2y and 3x minus 2 are vertical angles, so 2y equals 3x minus 2. But then I don't get that. But then there's some of you who are like, oh, I got a different idea. I can solve this problem. Anyone fall into that category? See, we got several people who fall into that category. What do you think, Elkie?
So you know that 6x plus 11 is its alternate interior with what's the corner next to 3x minus 2?
Here?
So yes.
Okay.
So then you know that 6x plus 11 goes there, and that 6x plus 11 then plus 3x minus 2 equals 180.
Yeah. So we got one nice little equation, 6x plus 11 plus 3x minus 2 must equal 180. Anytime you can write an equation with one variable, that's your best bet. And it keeps things nice and concise. So solve for one variable first, and then go back and solve for the other one next. Go ahead, solve this equation and check with your neighbor. Okay, so if you did this correctly, you should have simplified that left side of the equation first down to 9x plus 9 equals 180, and then solve, and you get x equals 19. Anyone have a problem with x equals 19? Great. So now we have more information we can solve for y in the second step. Anyone have an idea of what equation we could write to get us to y? Ben?
3x minus 2 equals 2y.
Okay. 3x minus 2 equals 2y. By what property?
Vertical.
Vertical angles tells us that. But we still got an x and y in there, and that's yucky. We just want to get it down to y. So what can we do, Ben?
You know that x is 19 degrees, so you can do 3 times 19, which is 57.
Good, just substitute in what you know for x. Ben already did some of the calculations for you guys. I guess we might as well just keep going from this stage here. So 57 minus 2 is what, Katie?
55.
So we know that 2y equals 55. Are there any questions about that so far? And then when we divide by 2, you have a question, Lauren?
Yeah, I don't understand how we get the equation.
Well, like any of them that we had here, or what we just did?
Yeah, that 2x minus 2 equals 2y.
2.
Or 3x, yeah.
Okay, this angle and this angle, Ben said, are vertical angles, and they're equal to each other.
Oh,
Okay? All right, so that's how we got that. But we want to get rid of this x in here since we know it, so then we substitute it in the 19. When you divide down here, what do you get, Sophia? Close. 2 goes into 50 how many times?
7.5.
Oh, okay. Do it all at once. I'm going to walk you through it, but good. So y equals 27.5. Any questions? All right. And we're going to look at another new idea and a strategy we can use to help us out in a situation. So it looks like this. Go ahead and draw this sketch, and then we'll talk. When I first looked at these pictures, I was like, gosh, I couldn't find an easy way to do it. And then in my research for teaching it, I was like, oh, duh. So let me show you, so you can have the same oh, duh experience as me. All right, so we've got this angle up here and this angle down here, no full transversal, so it's a little weird looking. But there is no rule that says you can't add lines to your drawing. So a great little line to add to our drawing is a nice parallel line right here. Because what will happen if we do this? I always draw lines I'm going to add to my drawing as dashed lines. So I'm going to add a parallel line. Because then I got all these great relationships I know about parallel lines, I can start to use some of them. So I add the parallel line. And then it kind of unlocks the problem for me. I don't know, did any of you go, oh, really? Or not? If you're not having a, oh, I get it moment, here's what I would say. Ignore the bottom half of the drawing under the dashed red line and look at just the top half of the drawing, dashed red line and up. Do you see any angles that are any of the kind we've talked about?
Ooh.
Ellie?
The interior. I don't know.
Interior angles? Like here and here?
No. Alternate interior.
Yeah, alternate interior. So here and here? What do you know about that?
They're the same.
They're the same. So this is 56. This right here must be 56. Well, that's part of why, so that is helpful.
So the other side might be 56. No, the
So-
other side must be 42.
Oh, Jack, why must the other side be 42?
Because on the other side would be alternate interior angles, so 42 would be equal to that other angle, which would also.
Yeah. So then just look at the bottom half of the drawing. We have parallel lines. This and this are alternate interior again, so that has to be 42.
And then you just add those.
And then you just add them. So angle Y has to be 56 plus 42. Be careful on these computations. Don't get sloppy and make little errors here. 56 plus 42 is 98. So angle Y must be 98 degrees. Any questions about that? Yeah, that little parallel line made it go fall apart for us. By this drawing, I want you to make a note. I want you to say, okay, to insert additional parallel lines. It's a great strategy that will help you solve problems often. Okay? Any questions? I have one more diagram that looks pretty similar to this, but there's a little bit of a difference. So we'll look at that one and then we'll call it quits. So here's the other diagram. Sketch it and be ready to tell me how it's the same and how it's different. Okay, so I asked you to tell me something that's the same and something that's the different. What's something that you see that's the same as the last diagram? Carolyn?
It's like in the same position. Tilted upward.
Yeah, it looks like pretty much the same picture except it's on an angle. And that's important because I don't want you always looking for parallel lines as horizontal lines. They don't need to be, okay? What is something that's different about this one compared to the other one? Something different. Katie?
This one's a little bit flex.
Yeah, good vocabulary too. In the last one, we were looking for the angle kind of inside right here. And in this one, we're looking for the reflex angle, the one kind of on the outside of it. All right. In either case, what could we use as a strategy to get us started on solving this? What could we do? Jillian? Yeah, add a parallel line going through the vertex there of that middle part of the picture. Okay, now angle-wise, what can you tell me now? Can you tell me now? One thing. Erin, what do you?
So 39 minus.
Yeah, its alternate interior one is right here. Good. And what else can you tell me as far as that goes, Angela?
That 180x.
180 minus 39 is what? Oh, over here? Yeah, that's true. That's true. I don't know if that's the most efficient way we could get it. What would you do after that, Angela? Wherever you want to go. What about this angle, Angela?
Oh,
It's 45. Okay. All right. So, well, we need this reflex angle like Katie was talking about. Anyone see a way we can get it here? Shree?
So you'd add 39 minus 45 and subtract that from 360
And you get 4F. Good. So your equation is 4F equals 360 minus the sum of 39 and 45. Because right here at this point, that all the way around that point down a line is 360 degrees. Go ahead and solve this one and check with your neighbor. Okay, so if you solve this problem correctly, you get 69 degrees, like you guys did. Remember that adding a parallel line can be really helpful. I want you to make sure that you're all thinking about, when you do your homework tonight, it says like an algebra student. So not like all of these random calculations like a lower school student, but the expression that shows up in the picture, 4f, should show up in your equations and you're solving for it, okay? So that's what I want to make sure you do in your homework. Also, if we page back, I forgot to have you add, by this picture, a note. So the first example we did, I want you to make sure you add a note saying, avoid using two variables in one equation. Right? Because there's usually another way to do it. That probably always told you right now. And remember, so we solved for x and then went back for y. You don't feel like x and y should both be in the equation at first.
This is doubles.
Yes.